In this lesson, we're going to talk about some application problems with sine, cosine, and tangent and right triangles. So one thing that's not going to change here is that we have the right triangle trig ratio still. We still have sine, cosine, and tangent. We still have right angles. We're just going to build on to that. So here's a typical story problem, I guess you could say, for right triangle trig. They want to know the height of the tree. So we have this shady looking guy here. Okay, he is looking up at the top of the tree at a 37-degree angle. And you can actually do this. I know some of you did this last year with Mr. Moyer, Miss Vedovitz, but you measure the angle going from the horizon up. Okay, so the first thing we're going to do is we're going to solve for x, which is part of the height of the tree. Okay, so thinking about if the horizontal distance here is 80, this also has to be 80. Okay, so we would have the opposite and the adjacent side, so I'd have the tangent of 37 equals x over 80. I'm going to go ahead and solve for x, so 80 times the tangent of 37 gives me 60 let's just say 3 feet. Now the problem is x doesn't really represent the entire tree, right? We also have this distance here, which is equivalent to the shady dude's height. Okay, so we know this is 6 feet. So what I really have to do is I have to take the original height of x, which was a 60.3 feet. I need to add in 6 feet because that's the horizon to the ground. And so I end up getting 66.3 feet for the height of the tree. So that's one version of a story problem. Sometimes, though, they put it into words, and I need to introduce you to a couple of terms. So those two terms are called angle of elevation and angle of depression. Now, everything you need to know about angles, when you measure them, you start at the horizon. Okay, so like this guy here on the ground, right? He's on the ground here. This is looking straight forward is the horizon. If he starts at the horizon and looks up, it's called an angle of elevation, right? Elevate means to raise up, so looking up is your angle of elevation. The guy standing up top here, now he looks like he's on a box, but like this could be on top of a mountain, on top of a cliff, on top of a building. Okay, looking straight out is still the horizon, but because he's looking down at an object, because he's looking down, it's called an angle of depression. Now, these are the terms they use a lot, angle of elevation, angle of depression. But what I want you to understand is the angle measures for the angle of elevation and the angle of depression are congruent. Here's why. This is a horizon, and so is this. Okay, and then if I were to draw in part of a triangle here, this angle of depression and this angle of elevation, those are congruent because our horizons are parallel, right? So these are alternate interior angles. So if you're talking about angle of depression or angle of elevation, it really doesn't matter if you draw your triangle like this with the horizon at the bottom or if you draw your horizon at the top, because these two angles are going to be congruent because of the alternate interior angles. So we're going to give a couple of problems to try here. Before we do that, I just want to take a quick second. We're going to identify each of the 4 angles here as either being an angle of elevation or an angle of depression. All right, so number 1, here we have, oops, sorry, I moved the picture. Here's our horizon, and if we look down, right, the bird's up in the air, it's going to be looking down. This is going to be an angle of depression. Okay, angle number 2, okay, here's my horizon. So to go from the horizon to the other side would be going up. So that would be an angle of elevation. Number 3, start with my horizon. Going to the other leg of that angle would be looking down. So that would be an angle of depression. And then the last one, start with my horizon. Go to the other leg. That would be going up. So that would be an angle of elevation. All right, so let's give it a problem to try here. It says a salvage ship's sonar locates wreckage at a 12-degree angle of depression. A diver is lowered 40 meters to the ocean floor. How far does the diver need to walk along the ocean floor to the wreckage? All right, so I have it kind of drawn out here for you, but this is what our triangle is going to kind of look like. Because it's an angle of depression, that's what they're describing. But again, they have marked those congruent angles here. Okay, so here is my right angle, right? This is my 12-degree angle of depression. The diver's lowered 40 meters. So this is a vertical line here. So it is going to be congruent to the vertical line over here because really what we've created are rectangles. So if this piece on the left is 40, this piece on the right here has to be 40. They want to know how far along the floor, that's my horizontal piece, they want to know this distance. So this is also horizontal. All right, so I'm trying to solve for D. My 40 is the opposite side, D is the adjacent. So it tells me I'm going to use the tangent of 12 is equal to opposite over adjacent. So 40 over D. Then you take 40 divided by the tangent of 12. And I get 188.2, where are we? Meters. 188.2 meters. All right, so the math of it really isn't changing at all. We're really just asking you at this point to take the words and to draw a representation.